Good morning, everybody. My name is Ivan Straznicky. I'm CTO Advanced Packaging for Curtiss-Wright Defense Solutions. My talk today is about the beauty of going small. And I think we can appreciate that, or we have been appreciating that for years now with trends like Moore's Law at the silicon level, and also 2D, 3D integration at the semiconductor packaging level. And these advances have really created some amazing technology, and I would say not the least of which are these appendages that we seem to have grown in the last several years. If you couple that with some of the existing and new use cases for things like small vehicles, as well as small spaces within existing vehicles, there's really there's a clear need for a rugged small form factor, and I'm going to argue for a new rugged small form factor. But first, we have to answer one main question and then talk about a few other things. First question we need to answer is how small is small? And I'll do that on the next slide by talking about small form factor definition. We'll get into some details about technology trends and use cases for rugged small form factor. Talk about what customers are asking for, which is obviously very important. Get into a list of preliminary requirements. Do a review of VITA small form factor standards, and then wrap up with a summary. So how small a plug-in module form factor do we need to have? And I would argue that there are three main objectives for defining that. The first one is differentiation compared to 3U. So 3U is pretty small itself. You know, we've gone from 6U to 3U systems, and there are a lot of technology trends that have allowed us to do that. But do we how far do we go beyond that? And I'll talk about that in my third bullet on this slide. Also, we clearly need to take advantage of technology trends, and I'll talk about what those trends are. And it's a two-way street with what those trends are doing as well as what's driving them. And then last but certainly not least, we need to create some packaging flexibility to potentially, not potentially, but to actually go beyond the board and backplane approach. So we've been talking about in VITA and in other groups a size of roughly 100 by 100 millimeters, 90 by 100 millimeters in the VITA 75.1 case. And is that small enough? Certainly that does gain you significant swap-C advantages, but there's a compelling story to go beyond that. And what I'm talking about there is about 30 to 50% of 3U. So the 100 by 100 millimeters is about 62.5. So and you know, why would we do that? It's really about, if you start looking at what you can design at that space, it does allow you a fair amount of packaging flexibility in terms of not being constrained by the board and backplane approach anymore. The other thing it allows you to do is to talk about getting more aggressive and going even smaller. And if you remember, I think it was 2 or 3 years ago, the Picnic group talked about a postage stamp form factor, which is clearly very small. We're not talking about the really small postage stamps, but kind of the medium-sized postage stamps. The other thing that you can do when you get to that level of smallness, if you will, is start talking about wearable electronics, which is potentially a huge area, you know, quite new to this group, I would argue. But let's not get too far ahead of ourselves, because we need to look at the bigger picture of the subsystem level and the system level before we talk more about the module form factor. And here the trend has been from roughly 3/4 to 1 ATR size systems, maybe even 1.5 ATR systems that house and enclose 6U modules with the backplanes that we know and love. We've been, you know, developing those systems for decades. We've moved over to smaller sizes like the half ATR system to house things like 3U modules, still with a backplane approach. And then we, you know, the small form factor and ultra small form factor systems or bricks and blocks that exist now use more of a carrier and mezzanine card approach. So those have been the trends at the various levels at the system and subsystem level. What's next? So what's next is going to depend on how creative we can get. But that doesn't necessarily mean recreating the wheel from scratch. There is a lot of good work that has been done with commercial small form factor standards within VITA and other standards bodies. So we should leverage what we can and not necessarily do everything from scratch. But there are some clear needs for doing things somewhat differently. So speaking of leveraging, this is a bit of a busy slide, the obligatory eye chart. But it talks about really what are the new applications like 5G cellular wireless, AI, artificial intelligence. We heard about that this morning. IoT, Internet of Things, as well as industrial IoT. Those applications are clearly driving, but also leveraging from semiconductor packaging and silicon trends. And there's a whole bunch of them there that I won't go through all of them, obviously. But it is a two-way street. There are some needs, and one of the speakers earlier this morning was talking about AI driving processing chips. That's a clear trend. But at the same time, those processing chips need to have the technology within them to be able to support the AI application. So it is truly a two-way street. And the defense and aerospace industry is not staying still and is basically very involved in this to and fro between those two areas through initiatives like the DARPA's CHIPS program, which is a heterogeneous integration program that is attempting to drive the industry, but is also leveraging from the industry, things that are going on with heterogeneous integration. Now, all of these thrusts are driving some common trends that we have known about for several years. So obviously increasing miniaturization, increasing integration, higher I/O density, higher functionality, and unfortunately larger amounts of power and heat, which continues to be a problem, and that's an area that I have been very involved in terms of thermal management. So let's move on to use cases. These are just actually a smattering of some of the use cases that are out there. Some of them quite new, some of them have been around for a longer period of time. And one of the things that these use cases have in common is that they require a large amount of processing power in a variety of form factors and a variety of functions to make them operate, and operate safely. And in particular, UAVs have a requirement for hardware to be DO-254 up to Design Assurance Level A certified. And you can see the bar is quite low in terms of the weight and the size where this starts to become a requirement. So there's a clear need that safety certification is a key driver for rugged small form factor. Now, when you talk to customers who are designing and making these vehicles, there's some clear asks that they have requested. And we've been doing this for a number of years, as have our competitors and others, asking customers, what do you want out of small form factor? And sometimes it's like way too much information. But I've tried to summarize most of the key asks on this slide. And I won't go through all of these because some of them have been requirements for Milcott's systems for a long time, things like extended temperature range and having a rugged interconnect. And then these at the bottom, those are more or less obvious for small form factor, but I will focus on these three here. And starting first and foremost with the small size, less than half 3U, that's become a common enough theme where customers are saying, we really need to develop truly small form factor and ultra small form factor systems. So the 3U is obviously too big, but 2/3 of 3U, still not cutting it. And one point I'd like to make, when you get to that size, it actually opens up some design options. And in particular, if you focus on optimization and efficiency from all different angles, it's impressive and it's interesting how much you can get done in a smaller form factor. I talked about the DO-254 DAL-A requirement. And then last but not least is that, and I think you've kind of recognized this already, and I did talk about it earlier, is that this is really a solution for new applications, much smaller than 3U. So it's not about cannibalizing 3U applications because those clearly have been successful and they have certain, areas and applications that make sense. But What we're talking about here, similar to my point about wearable electronics, are truly new applications that are opening up the market space for a standards-based form factor. And I'll argue it's going to be a VITA standards-based form factor, based on what Roger was saying earlier, for example. So that drives this list of, I would say, preliminary small form factor requirements. The module size of 30 to 50% of 3U. The safety cert requirement. Of course, we need standard mil COTS, ruggedness and reliability, the operating temperature range, environmentals, etc., as well as the other ilities, of course, that we've been talking about for decades: availability, maintainability, supportability, etc. Their rugged interconnect solution is a clear need, and you'll notice that I've mentioned VITA 72 vibration in the list of ruggedness and reliability requirements. And that may drive the need for a new connector. So that's something that we'll need to take a look at as well. And then last but not least, again, the diversity of applications that I talked about and showed earlier really drive a need for flexible packaging so that a variety of interconnects can be accommodated by this approach. Whether that's a mezzanine approach, the standard backplane and board approach, or even a cabled approach. Many of you know that there are several VITA small form factor standards already, and I've listed them here simply in number order. Starting with VITA 73, which proposed a size of 101.5 by 71 millimeters. That has not really gained much traction at all, with only 3 working group members. VITA 74 has been substantially more popular, with 22 working group members. There's an ANSI ratified standard, and there's also a marketing effort called VNX that many of you may be aware of. VITA 75 originally started as a module standard, with one proposal being the 100 by 90 millimeter size that I talked about earlier. But it morphed into a system and subsystem standard that has released several dot specs known as VDSTU, or VITA Draft Standard for Trial Use, at the subsystem level. So it's helped to define things like front panel connectors, and front panel I/O, which is important, of course, as well. Excuse me. But I'm going to argue and basically propose and talk about, you'll see that on the next slide, that Curtiss-Wright is going to be proposing starting a new rugged small form factor initiative within the VITA standards group. We're going to be making announcements in 2020. You can tell I'm being somewhat vague because we're not quite ready to announce it, so this is kind of a pre-announcement. But we did want to talk about what the requirements are and the background for where we've got to, and it'll make understanding what we do announce in 2020 a little easier. So this is my summary slide. I've talked about all of these things. I won't read them, but I'll let you read them and review them. And at the same time, open up the floor to questions. Thank you.